So, right, small footprint inspection techniques for Android. So, please just let me introduce Damien Coquille, myself. We work for a French company called Sysdream, so big disclaimer here, we're French people. I'm very sorry for the English, the language quality, and don't please stop us if anything gets just confused because of the language. Apart from that, you might have guessed, thanks to the title, that we are two people that enjoy reverse engineering, and we are actually. So we are going to speak about one little technique called small footprint inspection. This little technique is somehow very simple to explain, but usually very difficult to apply to many systems. In fact, on the Android platform, it is very easy to perform small footprint inspection, and we will see why we want to do that and how we will do small footprint inspection. So first, reverse engineering. What is it and why would you do that? Reverse engineering is somehow a field where you just have a look inside the things. You just have a look inside the program, inside the computer. And why would you do that? Most of you, I think, because of curiosity. You're too curious to just stick with running the program without knowing what's behind the curtain. And that's why those kids do reverse engineering. That's why you would do it, I think. Some people would also do reverse engineering because they are making security assessments. They just want to know why the application is running that way, because they have to assess that it won't break or it won't be broken into. Some other lame people will do cracking. They will just take an application and build some key generator or some security bypass. And to build that, they have to know how the key is verified or how the security is applied. So they have to know what is in the application. They have to know the internal mechanisms. That's another use of reverse engineering. And there is also this whole field of software. There's many applications that are built to communicate together, but that do not very well interoperate with our applications. Maybe some of you remember the magics of Microsoft Network, also well known as MSN. It was a very good chat network, but the client, the software, they used a proprietary protocol, and you couldn't actually interoperate with the server without reversing the protocol. That's another use of reverse engineering. Just make sure the things can work together. And how do you do that? You explore the internals of the programs of the application, and you try to understand everything. That's why you do reverse engineering. And how do you do that? You have hundreds of ways to do that. It depends on the platform, depends on the kind of thing you're reverse engineering. But for software, there are two main ways to do reverse engineering. There is static analysis, the one we won't really focus on today, but yeah. What is static analysis? You just have a look at the program statically. You look at the bytecode, you use tools to reverse the bytecode to make it humanly readable, and you make plenty of assumptions about how the program would work if you would run that functions or whatever. And there is also dynamic analysis, which is kind of the opposite of static analysis. In terms of computer software, when you do dynamic analysis, what do? You monitor whatever is available about the program. You monitor the memory, the execution path, anything. And then you run the program, and you run it again and again, just like you would do fuzzing. But actually you are observing the state of the application, the internals, and you try to guess what actions reflects in what internal of the application. If I click on that button, that variable in the memory, it's changed. And you try to guess how the application works internally. These are the two main ways of doing reverse engineering in software. For both of those ways, you make assumptions. But I like to compare dynamic analysis with a very different field, which is physics. I like to make this comparison between reversers and physicians, because both do some very similar things. They consider a system or a program or whatever, and they monitor what is available to monitor. And then they apply actions. They do things on the application, they do things on the systems, and they generalize from the observations. Those two fields are very similar, and they are also similar in a way that both physicists and reverse engineers encounter the same difficulties. Physicists like to picture one of the difficulties they face as measure uncertainty. as much as you can observe a system, the deeper you observe it, the more you modify its behavior, and the more what you generalize is biased. You have the same problem when you do reverse engineering. The more you inspect the application, the more you look at the internals, the more it will behave differently from the normal actual behavior. So any report that you can build on an application will be biased by those side effects. Those side effects are very bad. I hate the side effects when doing reverse engineering. But there's a kind of people that love side effects, developers. I kind of like developers, but sometimes they're very annoying. And they like to amplify the side effects. They like to take the side effects, amplify them on purpose, and even sometimes invent new kinds of side effects. They're very tricky, they make my job very hairy, terrible, absolutely terrible. Those people who build techniques that amplify side effects just to prevent me from doing my job, they are called people that develop anti-debugging techniques. And anti-debugging is globally just a technique to amplify the side effects. And because I don't like those side effects, and I don't like the people that make those side effects amplified, I want to minimize the side effects. But before we do that, let's have a look at what I do on day-to-day life, Android reverse engineering. What does it look like? Yeah. We use a ton of tools, a ton of very cool tools. There are the static analysis tools. You can really spend hours doing static analysis. You don't have to, but you will always have to have at least some deep look inside bytecode before you do dynamic analysis. So the static analysis tools, they are tools to help you read inside the bytecode of the application. So there are Smally, Backsmally, and every tool many of you may already know. And there are the dynamic analysis tool. Dynamic analysis tool usually help you to run the application in a specific environment and look at the variables, look at the memory, look at the execution path. There are virtual machines, many virtual machines, especially the Android virtual machine, which is the official one published by Google. There is the DDMS, Dynamic Debugging Monitor System, that helps you monitor the memory and whatever happens during the execution of the program. There is one very cool tool that I invite you to Google, which is APKill. It's a very cool thing that helps you injecting callback inside the application just to monitor the execution path. Those tools are very cool, and they make my job not boring, because what I do with those tools is very heteroclite. I mean, I wake up in the morning, I run the application in many different environments, and I inspect everything, the network traffic, I inspect the memory. I will pretty much look at everything, and I don't spend a minute doing nothing during the day, and I don't spend 2 hours doing the same thing in a single day. But yet, at the end of the day, I'm very unsatisfied with my job. Why? Because remember those developers, those sad, terrible developers that develop anti-debugging techniques. When I do reverse engineering, I'm facing anti-debugging tools, anti-debugging techniques. And how do I cope with that? I can't. There is no proper tool for now on the Android platform to prevent anti-debugging. So I have to spend hours patching Smally code. I look at Smally code and I patch it just to bypass the protections that developers put in their code. And I lose time doing that. Plus, there are plenty of tools I use that have a very heavy footprint. They include in the debugging process so much side effect. I mean, there are the debugging tools, the inspection tools, and even my own code that I wrote when defeating the anti-debugging techniques. All of these, they bias my report. Why? Because they add side effects to what I'm watching. I'm not watching the actual program. I'm watching biased version of what would be the execution of the program. That's why I want to go minimal. I want to do debugging without any side effect. I want to reverse the machine. I want to reverse everything without even touching at anything. I don't want the program to be able to know that it is actually being debugged. And that's why you would want to go minimal. Because side effects are bad. Because sometimes you want to go faster. Sometimes you just want to go faster. That very good debugger that includes so much time overhead that you spend hours watching at the code, watching at the instructions go on. You want to be stealthier because you want to look at the application without the application knowing what you're doing, and you want to go further. by going minimal, you can go modular. And by going modular, you can actually go deeper inside the application sometimes. And that's why we are going to have a very close look at what is the footprint of a debugging technique. Actually, it's something very non-measurable in terms of software. Because what is the footprint is the amount of hate you have against the side effects. It completely depends on what you are reversing. If you're reversing something very simple, where side effects are not very important, then you don't care about the footprint of your debugging technique. But if you're reversing something very tricky, and side effects are getting very hairy, and you cannot actually produce a complete, precise report, then the footprint becomes very important, and it grows with its importance. And you have to minimize the footprint in order to be able to produce a good report. So what does the footprint look like? Most of the time, it's just something that slows you down. It adds overhead, time overhead, memory overhead, and all those terrible things, but that do not very complicate your job. It just slows it down. And you have the worst case scenario, the terrible developer that put many anti-debugging techniques, and whatever you do, whatever you try to debug, you just make state inconsistent and the application crashes. Sometimes the phone, the device even freezes. And in that worst case scenario, you want some new tool. You want something that is very minimal for you to just reverse the application in a simple way. And there are many responses to the many problems. I mean, if the problem is, okay, my debugging tool is cool, but it has a very big space footprint, but that's no problem. Just go modular, guy. Build a very minimal debugging tool and add modules whenever you need them. If the problem is, okay, I have so much time overhead that my debugging takes hours, takes days, then just leave aside. Do not hook inside the code. Do not try to slow down the code. Just leave aside the code. If your problem is inconsistencies, just go pure. Use only pure functions. Do not modify the state. And if your problem is conflict in threads or whatever, just be very careful about what you do. When you modify, when you have to deal with threads, always check the thread you're dealing with. And there are responses to any of these problems. And the whole lot of responses makes possible to write a new approach of writing a debugger. An approach where you write a debugger not by patching existing bytecode or whatever, not by adding breakpoints at your code. You just add a simple code that leaves aside and that is modular. You do as little memory interaction as possible, you only use pure functions, and there you get something that has almost no side effect. It only has the side effect that you give it when you use it. It only has the side effect that you assume that you endorse, actually. And that is the approach we took when building a tool we called Fino. This tool has been built as some kind of a debugger that was minimal from scratch. Instead of writing a usual debugger and going sketchy, add plenty of functionalities, plenty of abilities, and note the side effects, then going back and correct the side effect, and then adding more modules, we write something with a very different approach. We started by avoiding side effects as a core design concept. And then we added functionalities, still avoiding side effects. And by doing that, we cannot go very deep because we always have the problem of side effects, but we can go as deep as possible without the application even noticing it is debugged actually. So how do we do? Maybe some of you don't know actually how an Android application looks like. It's very simple. It's a big archive where you put many things. There are activities, the things that are displayed to the user. There are services, the thing that run in the background. There are broadcast receiver, the thing that just deal with the messages of the system. And all of these are registered in the manifest. What we did with Fino was inject some dead code in the application. We took the application and we injected some dead code that is never referenced anywhere in the application. And by not being referenced anywhere, it is never called. It has to be called by the system. And it is called by the system in a very simple way, because what is left us to do for injected dead code, we can use even handlers, we can use broadcast receivers, but you decided to use a service. We use a service that we inject in the application that does nothing until you just call it using a system call. We just put a service here, an inspection service, a dead drop in the application that does nothing in the usual usage of the application. But whenever you call it, it will reply. And you have to call it using a covered channel because you don't want the application to know it is currently being debugged. So you cannot use network communications to communicate with your tools because that would be system dependent. I mean, you don't know if you are using Wi-Fi or GSM or whatever. You can go with local sockets because they are the same problems. You are system dependent. Maybe you lack some permissions even. It's completely out of the question to go through the graphical interface. So what could we do? We could use standard system calls for services on the Android system. And that's why it is so easy to do small footprint inspection in the Android system because there is that native remote procedure call for services. And that's what we used. We had to build clients and proxies for our debugging technique. But it works, it just works. How does it look like at the end of the day? We have the application with all of its legate component. And we have our inspection service that it just has been dropped in there. And it has an inspection API. An inspection API that is called as a normal service API on the Android system. So we can build Android clients for our debugging tool, but it's still not very handy to use. So we built an Android proxy, something that communicates with the API and provides the TCP API over the network. And then we built some Python API, and we built many tools upon that. So how does it go? Pretty well, but we still have a very last problem, the entry point discovery. Yes, we have a code that is never referenced anywhere. How do we know where to begin? How do we know what is the first variable we will look at? Once we have variable, we can look at the attributes, we can look at everything and explore the memory, but we have to get our first variables, the entry points of the program, the memory entry points. And how could we do that? There is no technique for that. Actually, there is one small tool that we used for now that is available from the 4.0 Android API, which is the activity lifecycle callbacks. It's a very cool tool that the Android API provides that helps us knowing what are the activities running in the application. And then we just use the activities object as entry point from the memory. And we explore the memory from there. We can call functions from there because our code is executed inside the main application thread. So the tool is called Fino in reference to that very cool person that was Inspector Gadget. It's actually a set of tools. There is Fino, the service we inject in the application. There is Gadget, the proxy I told you about. And there is our client side on the computer. So, sorry. Let's do some demo now.
Okay, so as you may have understood, I am the demo guy. I was going to experience some problems and solve them. Well, I don't know your machine. It's a...
Okay.
Can you give me the shell, please?
Here's the shell.
Thank you. Well, we have an Android emulator installed on this machine and running. In this simulator, we have already installed many applications I'm going to use for the demo. So I'm going to start with a very simple application called CCC demo number 1. And this demo is, in fact, using some obfuscated string. Maybe some of you have already reversed some Android applications and faced this problem. You know, many Android developers use some tools to obfuscate the code, and some of these tools are pretty cool and do a great job when they try to obfuscate strings. And I wrote a very simple application using a kind of obfuscated string. And this application is the one running on the simulator. What's the combination of the... Sorry.
J'arrive pas à switcher entre les chèques.
Hey. Well, Sorry again, it's not my machine. So demo 1, we just use the Python API to communicate with the remote application. And in this remote application, you have a dedicated class called opfu. And this class handles all the obfuscation stuff. So it's a bit of easy obfuscation, because we are just using some exclusive OR encryption. But we are going to deobfuscate the string very easily using our tool. Okay, thank you. Well, so this string displayed in the main activity is obviously an obfuscated one. So I'm going to close the application just right now. Make sure the application is not running anymore. Cool. Well, again, the Nemo effect. Wow. Okay, sounds good. So, demo 1 is completely removed from the memory. I will make sure that our proxy called gadget is up and running. It is in fact a TCP proxy for our injecting service inside the application. And I'm going to start a shell on this system for the first demo. Well, it's okay. It's a bit, the display is not good, but it's still working. Well, so when I run this shell, I have some variables already set. One of them is an app variable. This app represents the application. So I am able to manipulate to use the application in Python as we normally do in Java. Well, just have a look at the class used for the obfuscation. I'm going to get, using my brand new Python API, an instance of the class inserted in the demo called opfu. Yes, get class, not get class. Well, obviously it worked. All right. And as you can see, this class has a specific method called get, which is a static method. And I'm going to call this method without running the application, just by using our service injected in the application. Since the service is up, we can access every class we want. Let's go and call the get method of the obfus class. And here it is. But of course, we can do a lot more with this tool. I'm going to really start the application this time. Because it's just our service that loads the class and accesses the static method. So I'm going to launch the applications and do some other stuff with it. So here it is, it's the obfuscated string. I'm going to manipulate the title of the applications. So you can get the title with the Python API. It's sorry, I didn't get the activity anymore. Well, we can list all the existing activities by doing some code, and of course, another problem.
Capital A to activity. Capital A to activity.
Oh, yeah. Maybe the stress, Of course, the better. So, get the activity. It's the first one written in the list. And get the title of this activity. You can access all the properties of the activity right now from the Python API, just like we do in the Java code. And of course, we can set the title of this application. Let's say hello 2093. But nothing changed because, of course, the activity is not refreshed. Well, just refresh the activity. Crossing fingers. Oh, it's a bit slow. All right. And to finish this first demo, I'm going to close the activity. Here it is. Well, as you can see, we have some functionalities, very cool functionalities, providing us with a lot of means in order to see what happens in the activity. Well, in fact, for deobfuscating string, it's pretty cool. Well, I'm going to go to another demo.
Projects.
Yeah. Yes, thank you. So, demo 2, which is another kind of activity. Given a specific application using a kind of license managing system, we are going to spoof the license manager. You know, most of you have maybe already experienced this. We have a kind of class handling some stuff, and the only way to modify the behavior of the application is to patch this class. So just remove the SMADI code, install your own SMADI code, and rebuild the application with the APK tool. And this is very easy, because you have, well, not so easy. You have to build some SMADI code from scratch and patch the SMADI code in order to obtain the desired behavior. Well, we are going to do the same dynamically without using any patching. So here is the target application. Just starting. Well, and this target application asks for a license. If I enter some text and check the license or the key, okay, I have a small toast saying that my license is wrong, and this is perfectly normal. Well, I'm going to use another functionality of Fino, which is the ability to inject some Java code, compiled Java code, inside the target application dynamically. So, again, I will use my brand new tool Fino. Sorry. This time on the second demo. Here it is. I'm going to get the activity as I did previously. Well, of course. Just restart the activity. Maybe this time. Yes. It's a bit of a proof of concept too. Get the main activity. Yes. All right. So here it is. And besides it, I'm going to launch kind of code we developed. And this kind of code is presented just here. I've wrote a specific license manager called My License Manager. And I'm going to spoof the original license manager with this one. I'm going to try to be very quick. So first of all, we have to load the APK created for this this data demo. So I'm going to load my license manager. So ask the system to load this license manager, which is located in normally in this class. We got the mistyping. It's better. Yes. So here it is. I'm going to create an instance. In the activity, there is also damn it, the completion. Normally a license manager, which is an instance of the target class, and simply I'm going to instantiate my license manager and try it with a random key. check key, and that's it. And the last demo is a kind of old school stuff. You know, most of your reversals have maybe already manipulated some games and maybe cheated. Well, this can be done on Android systems. So I installed a famous game called G-Worlds, and I'm going to do some pretty interesting things with this game. Well, if it launches. Yes, that's it. So I'm going to demo 3. So I wrote a kind of trainer in order to cheat at G-Worlds for the first time. So I can start a new game. Well, no, not this one. This is my settings. Nope. Nope. So, as I said, starting a new game, normal mode. Here it is, 0 points, bonus 1, and the longest chain I've made is only 0. Well, anyway. Just launching my trainer. The trainer is going to use gadget to connect to the application. Once it's done, once this is done, I can just press enter. Well, again the demo effect. Damn. No, that's well. Anyway, I'm going to use it with the final and do it manually. This is less tricky, but it works. So we are going to cheat on G-Worlds. Come on. Yep.
Not for today, I think.
Well, yes. Here it is. So we have the application, and we are going to grab the activity again. So just by filtering some stuff stored by Fino. It's quite slow, and of course it doesn't work. Well, just restarting the activity. Sorry about that. Yes, I will cancel the game. Well, the last demo is the other one. Yes, want to exit. So just restart it. The service is still alive, hopefully. Well, to be sure, I'll just restart the Fino client. Damn, so. Just wait. Okay. Come on. You have an idea about it?
Yeah,
yes.
okay.
Well, just pray to have an activity.
Capital A.
Thank you again.
Okay.
Well, at least we have enter screen activity for score loop, not this one.
Just quickly change the score. Just quickly change the score. I think it will work.
Yes, I'm going to change the score, but I need this activity to change the score of the game, my game activity.
Yes.
Yes. Well, hopefully it worked. Get the first one. This is very slow because we used an emulator. At first we hoped to do it on a real phone, but unfortunately it was stolen before the conference. So yes, I won't give too many explanations about how I found these properties, but here it is. If you want to set some score,
Maybe.
Can easily cheat with this game. It's just again very slow. Come on, that kind of suspense.
Anyway, the point was here, usually you wouldn't do that on an emulator because that is adding side effects. We would have liked to do this on a real phone because we wouldn't have had any side effect. But yeah, as we said already, it was stolen.
So it looks like the fruit device that you sacrificed wasn't large enough to accommodate your demo. So we're at the end of this presentation, but this room...
Thank you.
Just in time.
Yeah. I don't think we have much time for questions, maybe.
Well, this room isn't being used for anything right now, so if you have questions, we'll do some questions. Do the stream people, you have any limitations? No? Okay. So if you have a question, line up at the microphones.
So I have a question here. The question is, how do you actually inject the service into the application? Is it only statically? And if it's statically injected, can you, for example, inspect code that is dynamically loaded, like if you call loaddex file or something like that?
Yes, it is statically injected in the application because otherwise we would have to get root access to the phone or whatever. We don't want that. We don't want side effects on the device. So we inject the service before we even install the application.
And how do you initially run your service? Is the application started by calling your service?
Yes.
Or do you hook all the entry points?
No, on the Android system, a service can implement what is called an action filter. And we just call that service using the action filter so that and the Android system actually starts the application thread and just runs the service loop inside. So we don't have to get the activities running, we just have to get the service running inside the main thread. And that's what the system does for us when we just invoke the service. That's why the Android system makes it so easy.
But then you still have, for example, other threads and other components that might be uncontrollable by your service, right?
Yes, that is the whole point of getting the entry points.
Yeah. Okay.
Thanks. All right, let's have a question from over here.
So would it be possible if you have root access to do it like they do the injection live on the phone, or even without root access?
No root access needed. You can do it on an unrooted phone. You just have to take the APK, disassemble it with the APK tool, inject your service, our service Fino. But we built a specific tool. We did not have time to show you how it is done by using this tool. But in fact, you have to just to run a script, a shell script that performs all the stuff, and take the APK, disassemble it, inject a bit of smiley code, just like you do when you patch applications. And then we build the APK with a specific certificate. Of course, we lose the certificate, the original certificate, but we use a dedicated one to install it on the phone. So you can just enable the Android options called install from any sources. I don't know. There is a specific option in the Android operating systems that allows you to install any kind of applications coming from outside the market. So you can just enable it, install the application using ADB or just a file manager, and then start it on your phone, and here it is. You just plug your phone with the USB cable, do some stuff with ADB, just forward a TCP port to the gadget proxy, and here it is.
Okay.
You can just connect with the Python API.
Okay, but there's no attack surface. You still have to circumvent the application signage. If you would use this as an attack.
No.
The application can check the certificates and maybe detect if it's not legit. No.
Okay, thanks.
But at least we are able to modify the application before the application starts.
Yeah. What you showed is more related to the Java part, the dynamic part of an Android application. Do you have some facilities related to the extension that you can develop with the NDK in C++? For
the NDK part or NDK extensions, we did not manage to demonstrate some stuff, but we can do a very nice fuzzing with this tool. And it's particularly practical when dealing with native parts of applications. So we can just circumvent the user interface and just call native implemented APIs in order to trigger bugs or anything else.
Okay, so you reverse to the old way of disassembling something native, if you have to.
Yes.
Yeah.
Of course.
But you can swipe it.
Yeah, because we stick with the entry points and we use exclusively the Java reflection, so we can actually read the memory as a raw thing. We cannot read the NDK variables. We're stuck with the Java part, the dynamic one.
Okay, thank you.
Looks like we have a question from the internets.
Wouldn't it be possible to detect the injected service whether via static or dynamic means?
Dynamically, it can be detected because the package manager knows about the service. Well, to avoid this, it's easy to modify the name of the service. We call it com.session.finer, but you can call it whatever you want. So the only way to detect the service is a way based on its name. So if you change the name, you make it statier.
Thank you. We have another question in the room.
If I understood correctly what you did, you're reading and manipulating memory. Are you also able to suspend and resume threads?
No, actually we're not, because we only inspect the memory, and as we do not run the application in any specific environment, we do not use the debug port or whatever, we're not able to suspend the application.
Well, I have just something to add to what you said. There is a way to suspend threads if we can get under or just a reference to the thread itself. So we can just pause the thread, resume the thread if we have it in an entry point. You know, because we're using a service, and this service only allows us to communicate with standard types. We cannot serialize all the data between the proxy and the service. So we have to store some references in the service and call them by reference from the proxy side.
So in fact, it is possible just because you can get the reference from the application when if the thread is in.
Yes, well, yes. We have the application object, so we can get whatever we want with the window manager or anything else. For your information, the refreshing stuff that we did on the activity is not implemented in the standard API. We just called a specific method called post-invalidate on the window on the main view in order to force the system to refresh on the sub-views or activities.
Okay, thank you.
Any more questions?
You talked a lot about stealthiness, and is stealthiness really a practical issue for you when reversing applications? Is it more an issue for benign software or for malware? So what do you use it for?
90% of the time, stealthiness is not an issue. 90% of the time you get applications that do not really do anti-debugging, except for usual prog world and all that stuff. But 90% of the time stealthiness is not a problem. But those very least 10% of applications that do anti-debugging, those applications that will crash if you run them in DDMS, those applications that actually detect debugging environment, for those ones, it's very useful to have a tool that actually does not perform proper debugging. It's just service injected.
If I can add something else, there is another possibility, another feature offered by this tool. Of course, the stealth is not obviously the main concern in most of the cases, but sometimes, anyway, this tool provides a way to test modifications or some tampering on the application dynamically, which is which is faster than just patching the smiley code and rebuilding the application, installing the application, delisting the application, do some patch again, and so on. So it's also practical for us to use it, even if the stealthy part of the application is not a concern for the test. Anyway, to be stealth is very important to have unbiased report, because we generally do some Android application reversing for many clients, and they expect a report with which represents the exact I don't know the inner working of the application, not biased by an injected tool or anything else, or just a patching. When you patch an application, you can cause side effects which could be dramatic in your conclusions.
Okay, thanks.
All right, thanks again to Pierre and Adrien.